sir. We are going to present about linear algebra application. So first of all, my name is Ngô Đình Anh Khoa, and we also have Mai Huỳnh Thái and Trần Duy Trung Hiếu. So we have three content. The first one about the theory, the second one about our application, and the third one is how it's worked in the real life. So Thái will continue.
Okay, so first one is the theory. We need some theory for this problem, for this applications. Um, we need to understand the leading entry. The leading entry of the row is the first one that is non-zero of that row. Yeah, it's simply like that. And the second one is the echelon form of the matrix. As we see right here, we got three chapter for this one, and you can read that. But it's simply like the first leading entry of the column is the like the previous one is the non-zero stuff of that column, and the reduced echelon form is much bigger, like it's much like yeah, good than the previous one. So is the non-zero number that is on the row, and we see like we got one in the nearly in the middle of the row. So yeah, it's is much different than the echelon form of the matrix. Yeah, so that is our theory, and the final one is the yeah, you see like we got x1, x2, and x3. That's a accept, and for the echelon form of the matrix, we got x1, x2, x4, and x5. Yeah, so that is the theory we need for this application chapter. And the next one, we're gonna go to Khoa.
So come back to me. So in this lecture, we will examine one application that can be solved by a system of linear equation with four or more variables. Several years ago, the engineering students at university were asked to analyze the flow of the traffic through a traffic circle near the university. So they started by making a schematic diagram with arrows showing the direction of the traffic flow in, out, and around the circle. They were told that 75 vehicles per minute flow into the circle from the north and 92 vehicles per minute flow out to the east. Realizing that there was a high volume of traffic flowing in from the north and out to the east, the student made a recommendation to reverse the direction of the traffic in the circle between the north and east intersection. They also recommended adding a traffic cut through between the street on the east and west side on the circle. One day changes were made. The student asked the university to take some new measurements. It was confirmed that the original two measurements were still valid, but two additional measurements were made. The traffic flow between the west and south streets it was determined to 56 vehicles per minute, and the traffic flow between the south and east street was measured at 23 vehicles per minute. The student decided that even though there was no traffic measurement for the remaining row, they would try to calculate the machine traffic flow data. They started by assigning variable to represent the traffic flow on each of the remaining row. They could then create a system of equations which they have hoped would allow them to calculate the missing information. The first equation they created equated to the total traffic flow into the traffic circle equal to the total traffic flow out. They also wrote four equations for the traffic flow through the four intersections. Traffic flow into the west intersection equal traffic flow out of the west intersection. The traffic flow into the north intersection will equal to the flow out of it. This will be the same to the east and the west and the south. So to make the first step, we should simplify the equation, moving on the variable equation to the left side and combining all the constant on the right. So the system of five linear equations can now be put into the matrix form. This matrix is relatively simple since the variable in the equation all have a coefficient of 1 or negative 1. On and the remaining matrix entry left on of the vertical line or on 0. The constant in the equation then becomes the entry to the right of the vertical line. A matrix like this, where most of the entries are zero, is called a square matrix. Now that the equations are presented as a matrix, so it will reduce to the equivalent form to make it easy to find the traffic term of x1, x3, and x5. So from now on, this metric is an equivalent form. So you can see the column 1, the column 2, the column 3, and column 5. That's only have one. It is also either pivot columns. So there was infinitely many solutions. Those are the dependent solutions. So the x4 is a free variable. So here we'll continue our presentation.
Um, so then we will display the free variable x4 with the parameter quantity. Similar to our equation, we will change x4 into t. So we will have equation x1 through x5 with parameter t.
H2 and H5 are constant and function with parameter t. So next step, we have to find condition for parameter t. For example, we know that t must be an integer value because the fractional vehicles don't make sense. And t cannot a negative integer since on a one-way street, traffic can only flow in one direction. T could be 0 or 10 or 69. T could be 0 or 10 or 69, but T cannot be 70 since value for T of 70 or greater could produce a negative traffic follow value. So the range of values for T that must be reasonable results. Firstly, we simplify the equation containing more than one constant by combining the constants. We will put equation into matrix form. The variables in each equation have coefficients or either 1 and negative 1. And the remaining empty are on zeros in left vertical line. And the vertical right is constant in equation becoming the entries. We start changing the entry in the first row and column to a 1 by using a swap operation to exchange rows 1 and 3. To be in reduced row echelon form, all the entries below that leading entry must be 0. And we use the pivot operation to add negative 1 times row 1 to row 2 because all the entry below the leading entry in first row are now 0. And similarly to the previous the step, we train the constant to the right of equation. And next step, we simplify the equation containing more than one constant by combining the constant. The system of equations can now be put into the matrix form. Once again, the variables in each equation have coefficients or either 1 or negative 1. And we use the swap operation to exchange rows 1 and 3. And similar, use the pivot operation to add negative 1 times row 1 to row 2.
So we think that we have in our application. So from that have we determined about this application? What do you think it will be work in the real life, Thai?
Oh, I think it's like like we can solve some electrical circuits, or like we can do with the math problem that is have some unknown variable, and we can calculate that one. Yeah, it's so very easy for us to do that stuff with linear algebra. Really? Yeah.
Yeah.
So that's my opinion about that.
So I think that this application will help us a lot of things in the real life. If you want to, I think that if we want to invest in something and we use this metric, it will be good.
Yeah, I agree with you.
So our presentation is end. So thank you for listening, sir.